All right. So, hi everyone. First of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, which is India's largest online learning platform for IIT JEE. And on this particular channel, every concept of physics, chemistry, and maths are being taught to you completely in English. Now, this is a series that I host for class 12 students. And the topic that we are discussing right now is ray optics. And this is lecture number 6 of ray optics. And today we'll be talking about a refraction through plane surfaces. All right. Before we get started with today's discussion, let me introduce myself for those of you who might not know me yet. So my name is Rohit Dixit, and I studied mechanical engineering from IIT Delhi. And for almost past 8 years, I've been teaching physics for the IIT JEE Mains and advanced examinations. Now, before the last year, all this experience was in offline teaching, and offline I have been associated with some of the topmost institutes in the industry. Okay, I myself was All India rank 447 and All India rank 192, the two stages of the IIT exams that I took. I also qualified NTSC Stage 2 as a student, and I was in the top 1% in the NCP as well. Now, in these offline years of teaching, I have coached many students to top ranks in the IIT exams, both mains and advanced. And now I hope to continue doing that here online with you guys. All right, so this is how you guys, you students, can make sure that your studies are going uninterrupted and you are achieving those dream ranks and getting to your dream colleges. So the first step, what you can do is you can get yourself the Unacademy subscription. This subscription will help you with benefits like live classes, where you get to interact with your educators, and you also have live polls and leaderboards in these classrooms, which keep them highly interactive and quite efficient. Okay, then you have test series and analysis sessions, and of course, you have live doubt clearing sessions. So these sessions will make sure that your doubts never pile up. So for all Unacademy Plus courses, every fourth session is supposed to be a compulsory live doubt clearing session. Okay, so that will this feature ensures that your doubts never pile up. So in every after every three teaching sessions, there is one session entirely dedicated for your doubts. They may be about your theory, any doubts that you may have about theory, any problems that you may be facing with your problem solving skills. Okay, so anything that you are concerned about can be cleared out in these sessions. Okay, next, apart from all these benefits, of course, another great chance that you're getting with this subscription is the opportunity to study from the topmost educators from all across the country, from the comfort and safety of your home. So I think that's a wonderful opportunity. That's something that we guys never had a chance as students. So you guys should make the most of this. Okay, and how do you get these benefits? So the first step towards getting all these benefits is to install the Unacademy app. Now, the moment you do that, you unlock for yourself a lot of free features. So there are a lot of free courses, okay, running on the Unacademy app, which you can simply take part in just by installing the app. You don't even have to take the subscription. Then there are special classes that you can attend. Okay, now, all these special classes are absolutely free. Anybody who has installed the Unacademy app can attend these. So most of the educators keep taking special classes on a regular basis. Like I usually take 3 special classes every week. So you can simply install the app and be a part of any of these classes, okay, without having to buy the subscription. And then, of course, you have quizzes. So like the one we host every Tuesday. So these are all the features which you can simply well, just after installing the Unacademy app, you don't even have to pay anything for this. All you need to do is use my code RDLive to unlock all of these free features. Okay, so that's all you need to do. Okay, next. So this will give you a flavor of what your plus subscription is going to be like and how your studies with the plus subscription are going to go ahead. Now, if you like that, then what you can do is get yourself the plus subscription, and this is how you do it. You can go to the plus section of the app. Once you get there, you will find another window where you can select your goal as IITJ and then click on that get subscription button. Now, the moment you do that, you will be redirected to the payment page where you will find a box which will say, "Do you have a code?" So that is where you can uh, uh, enter this code RD Live. That is my code. This code will give you a 10% off on all your subscription. Okay, so that is the benefit of using this code. Now you can choose from two subscriptions. One, you can go for either a plus subscription or an iconic subscription. The fees of these subscriptions have been shown below, and also you'll realize when you click on proceed to pay, you have a lot of no cost EMI options to choose from to make these payments. Okay, so you can break this payment into a lot of no cost EMI options, okay, so that you don't feel the burden of this payment. You don't have to make this payment in one go. All right. Now, for those of you who don't know what the iconic subscription is, this is a new feature that Unacademy is offering. So this subscription will take your IIT preparation to the next level. And how does it do that? So you'll be allotted a personal coaches. Okay. These personal coaches will closely mentor you and monitor your performance all throughout. And you will also be able to attend a lot of IIT workshops. You'll be receiving expert guidelines from time to time. You will be getting a study planner, which is very, very important. I know a lot of students can use that. And then, of course, you will have regular test analysis sessions. So, with all these features and the personal guidance and mentoring of your personal coaches, your IIT journey will definitely be smoother. Okay. Now, for all the students who are coming to class 11th and are worried about, where to go, what to do about their studies, so they can find a one-stop solution here. What they can do is they can go for these combo subscriptions. So these combo subscriptions take care of all your needs, be it your 11th, 12th CBSC studies or be it your IIT preparations. Okay, so there are four combos that are available for you to choose from. The first combo offers you the iconic subscription for IIT JEE preparation and the plus subscription for 11, 12 CBSC. The second combo offers you all three iconic subscriptions. The fees of these combos are as mentioned here. Then you have a combo where you get plus subscription for all three, your IIT class 11th and class 12th. And finally, you have a combo where you get plus subscription for your IIT and iconic subscription for your CBSE 11th and 12th. Again, the prices are as follows. So you can choose a subscription that suits your needs and make sure that all your studies from your class 12th, 11th studies, your boards to your JEE Mains, JEE Advanced, everything is taken care of. Okay, all right. Next, these are a list of the upcoming tests in this month. Okay, now don't make sure that you are attending all these. Okay, so these are some important papers that you don't want to miss. Okay, so the Unacademy JEE Combat is going to happen on the 17th Jan and the 31st Jan. Okay, then you have the race test, which will be happening on the 10th, which has already happened, and the next test is on 24th. Last point, this has also already happened. Now, EM Advanced 2021 tests are happening every Saturday, so you can make sure to be a part of those. And then you have uni DPP discussions, which are happening from Monday to Thursday every week. Okay, so make sure you're not missing out on these. Okay. Next, if you are following us on the JEE English channel of YouTube, do not forget to connect with us on the Telegram app using this link. So this link will make sure that you are getting all the notifications of every session and lecture which is happening here on the JEE English channel. Okay. Now, why don't we get started with today's discussion of ray optics then? So today, hi Sambhav, how are you? So today we'll be talking about refraction through plane surfaces. Okay. All right. So if you remember last time we talked about this, we talked about the critical angle and total internal reflection, and I told you that critical angle. So if this medium has a refractive index of N2, this one has N1. So when going from your denser medium to rarer medium, this thing happens. So sine IC would be equal to N2 over N1. You should remember that. Okay, so that will give you critical angle, and if angle of incidence is greater than IC, then TIR happens. Total internal reflection will take place, right? We talked about this. Now today we'll be talking about some applications of this. Okay, so one great application is something called a circle of illuminance. Okay, so think about this. Think about this. So think about let's say somebody in water. Okay, so imagine yourself in water. Okay, now imagine you are here. So any light ray that is originating from you, so it can either take this path and get out, or it can take this path and get out, or it can take this path and get out here. Now, any ray that goes beyond this, gets reflected back into your medium, right? So what you realize is that only rays to this circle will go out. If this is a circle for which you have a cone with half angle equal to your critical angle, correct? Now, since only the rays that are going into this cone are going out, so from reversibility, what I can say is that every ray that can enter this cone will come to you. Agreed? So any ray entering this cone will only come to you. So any ray which is not entering this cone will not reach you. So what that implies is that when you are looking at the outside world from underwater, let's say, so you will be watching everything from this cone. That's it. All the light from outside world would be coming from this small cone. Okay. So what you realize is that in fact, if you are looking here, now pay attention to this. If you are looking here, you are seeing something which is here. And simply, similarly, when you're looking here, you're seeing something which is here. So this entire region is covered. So you are seeing everything outside this region through this cone. Okay, and you realize if you look further away from this cone, then you will see reflection. Okay, so this must have happened to you. Have you ever been underwater in a swimming pool? So hello AP, hi Tanya, hello Raj, hi Motilal. So if you've ever been underwater in a swimming pool and if you try to look at a point of water which is far away, what you see is in fact the reflection of the bottom of the pool, right? Have you ever seen that? So it is the light ray actually coming from the bottom of the pool that reaches you. So that is one interesting bit. So when you look away, you will be seeing this point, in fact. Now, interestingly enough, what happens is that if I cover this region, then you won't be able to see anything outside or in the outside world. Okay. So what I can say is when an observer, when an observer is located in a denser medium, then everything in the rarer medium is seen through the circular base of a cone as shown. Okay. Now, this circle is what you call the circle of illuminance. Okay. So let's just write that here. This circle is called the circle of illuminance. All your vision is of the outside world, of the lighter medium, is happening through this circle. Okay. Hi, Amod. How are you? Okay. So you realize if somebody blocks this region, then you won't be able to see anything outside in the other medium. Okay, so if you're underwater, suppose, and if I could find the radius of this circle, and if I could just put a circular uh, opaque object here and block your vision, then you will not be able to see anything in the outside world, right? So I want to calculate the radius of this. So if I want to calculate the radius of this, what should I do? So let's see. So let's see, this is the radius of the circle of illuminance, right? And you are at a depth h. Then what you know is that here at the edge of the circle, the angle of incidence would be the critical angle, correct? So which makes this angle of the cone also the critical angle. Half angle of the cone is the critical angle. So what you realize is that tan IC from the diagram we can see from the diagram from the diagram what you will realize is tan IC would be equal to R over H. So here you have R. R would be H times tan IC. This is the radius of the circle of illuminance. Now all you need to do is block this circle for somebody to block their entire vision of the outside world. Okay. So I hope that is clear. So if you have any doubt regarding this concept, then you can let me know. Okay. All right. Yeah, the doubt. Now, another application of critical angle would be in optical fibers. So you know that all your internet and communication, most of it is happening through at a very fast pace with the help of optical fibers. And the optical fibers work on the principle that if you can ensure that there is a particular refractive index, then what you do is you can send light signals here, and any light signal that enters this circular phase can only come out from another circular phase only. Okay, it doesn't matter whether you have bent the optical fiber or done what over this. So any light ray can travel through multiple total internal reflections and travel along the optical fiber. So that is a problem that we are going to try and address. Okay, so our question says find out the minimum value of n for which a ray entering the circle, a cylindrical optical fiber from one circular phase comes out from another circular phase only. So the aim is that any light ray that should enter from this phase, from this particular phase, should come out from this particular phase only. Okay. So what you want to do is, if you realize here, if the angle of incidence is I, if the angle of incidence is I, then the angle of refraction is R, then here the angle of incidence would be 90 minus R. So if this 90 minus R is greater than your critical angle, then what you realize is then this will get reflected. So this also becomes 90 minus R. So this also becomes 90 minus R. So as long as your 90 minus R is greater than the critical angle, your light ray will only keep getting reflected. Agreed? So I can say if 90 minus R is greater than IC, then this condition will be achieved. Okay. Now you realize what is the minimum value of 90 minus R? So can I say for 90 minus R equals minimum, because R has to be maximum, correct? If R is maximum, then 90 minus R has the minimum value. And if for such a value also it exceeds the critical angle, then I can definitely say that for all other angles, it will definitely exceed the critical angle. Okay. So if 90 minus R min is greater than IC, then I can say EIR will happen for all incident rays. Agreed? Now, you will also realize for R to be maximum, the angle of incidence has to be maximum. Okay, so since I know sine I equals n sine R, for R to be max, okay, you will realize for R to be max, I should also be maximum, right? And you know what the maximum possible value of I is? That is equal to 90 degrees. Okay, you cannot have an angle of incidence greater than 90, right? So at angle of incidence 90, you will have the greatest angle of refraction. So what I will realize is therefore R max is equal to 1 over sine inverse of 1 over n. Agreed? Or it is equal to the critical angle itself, right? It is equal to the critical angle. Now I want this to be just greater than the critical angle again. Okay, so we will add one page. Again, I hope everybody is following the logic of what we are trying to do. What we are trying to do is if I can ensure that this ray, which has the minimum angle of incidence at the cylindrical face, undergoes a total internal reflection, then all other rays will definitely undergo total internal reflection. So all I want is I want 90 minus IC greater than, which obviously implies that IC should be greater than 45 degrees or less than 45 degrees. Okay. So if your uh, critical angle is less than 45 degrees, then obviously all your rays will suffer total internal reflection, and since sine IC is 1 over n, therefore I can say that n should be greater than root 2. That will be the condition. Yeah, this is the condition. If n is greater than root 2, then what you will realize is that sine IC would be less than 1 by root 2, which would imply that your critical angle is less than 45 degree, and all such rays will in fact suffer total internal reflection. Okay, I hope that is clear. Okay, let me know if there is any confusion about this. This is the condition. If you ensure this, all you need to do is make sure that your cylindrical surface has a refractive index which is greater than root 2. Then any ray that enters through one circular face can only come out from the other circular face. Okay. Now you can have the ray entering at any angle. Okay, it doesn't really matter. You could have had this ray. Okay, you could have had this ray, any ray that you can think of. Every ray entering at any angle on the circular face would eventually come out from here only. Okay, so here it can come out. You realize here it will be incident at R, and what you'll realize is it will come out at I only. Okay, so that is something very interesting. Okay, all right. Now let's talk about the next thing. So next we'll talk about the apparent depth and the normal shift. Okay. So when you're looking for at something inside the water, you realize your swimming pools appear shallower when you look from outside. Okay, it appears that the water level is not that deep. Okay, but when you jump, it turns out it is deeper than you expected. Similarly, anything that you see through water appears to be a little shifted above. Okay, so our aim is to try and calculate that apparent depth or normal shift. Okay, so imagine you are viewing an object and the object is placed somewhere here. Okay, so here is an object. Now you consider two rays coming out of the object. One that is coming out normally. So a normal ray would simply get out here undeviated. Now we consider another ray which is coming out like this, and after refraction it becomes okay. Now this, when you look at these two rays, okay, it appears that this is coming out from here. So that is where you see the image. Okay, so the apparent depth of the image is a d dash, where d is the real depth of the image. Now, what we are doing is that if you look at these triangles, if let's say this is some x, So what you realize is if you look at triangle IAB, in a triangle IAB, you realize this tan r is equal to x over d dash. Also in triangle OAB, you realize this, that tan I equal to x over d. Now, this there is an approximation that we are taking. We are going to look for a near normal viewing. Near normal viewing means your eye is placed almost near the normal. Okay, so you also realize, though I've shown a huge eye here, practically the eyes are not so big, right? So you have to be very close to the normal. Okay, so what I'll say is for near normal viewing, for a near normal viewing. So if you're looking at the object from almost near the normal, okay, what you realize is that I tends to 0, and if I tends to 0, R also tends to 0. Okay, I and R both tend to 0, which implies that tan theta, tan I is roughly equal to I, which is also roughly equal to sin I. Correct? Okay. So similarly, and of course, tan R would be roughly equal to R, which will be roughly equal to sin R. Now you also know N1 sin I equals N2 sin R. Okay, so if I substitute these values, therefore, what I can say is N1 times x over d is equal to N2 times x over d dash. So what you realize is a d dash, which is the apparent depth, is N2 over N1. Okay. Now this formula works whether you're looking at things from the rarer medium or from the denser medium. Of course, if you are watching it from the rarer medium, then you realize N2 is less than N1. So this will appear up, the depth will appear less. Otherwise, it will appear more. Okay, if you're watching things from the denser medium, then you will see that the distance will appear higher. Okay, so the shift again can be in both the directions. Okay, all right. So I hope that is clear. This is a very important formula. We will be using this a lot. We need to remember this. Or what I can say is mu relative. D dash is D over mu relative. Okay. Mu relative of the medium that you're watching from. Okay, where the observer is placed. Okay. All right. Now again, what you will realize is again this formula. So let's write that formula holds true whether the observer is located in the denser medium or the rarer medium. Okay, so please remember that. Okay, so when you are looking from the rarer medium, then the objects appear shifted up. If you're looking from the denser medium, then they appear farther. Okay, and I can also say the apparent depth is d over mu relative. Okay, or d into mu relative. I can say depending on which mu I'm talking about. So this is what I can say. The mu r is the relative refractive index, relative of the observer. Okay, please remember that. Okay. All right. I hope that is clear. With that, let's move on and let's see. such questions. Okay, so there are a lot of questions that are asked from this fact. So I'll tell you what happens is, so let me add a page here. So a typical kind of questions now that are asked regarding this are the questions related to bird and fish problems. So let's talk about that for a bit. Bird fish problem. Okay. So this is a very common variety of questions. So here what you're usually told is that you have a container. Okay. And in the container there is some water. Okay. And then you have a bird located outside this container. So here you have a bird. And then you have a fish located inside this container. Here, let's say you have a fish. Here is a fish. Now, the fish and the bird are moving with respect to each other, and you are expected to find their relative velocities or the velocities of one as seen by the other. So, the idea of doing this is okay. So, first we imagine that the distance of we need a reference point. So, we take this and we take this. Then we have sometimes the water level is also changing. Okay, so let's imagine that you have the bird which is at a height z from the ground. Then you have the fish which is at a height, let's say x from the ground, and the water level is at y from the ground. So first, let's try and understand what is the distance that the bird sees of the fish and that the fish sees of the bird. So let's say distance of fish with respect to bird. So when bird is looking, it will see this height normally, right? This height remains changed for the bird. Now this height obviously changes. Okay, with if the refractive index of water is mu w, then what you realize is that this depth will become z minus y, z minus y plus y minus x over mu w. Okay, so that depth will appear shallower. So this will be the distance of the fish as seen by the bird. Similarly, what is the distance of the bird seen by the fish? Let's talk about that. So when fish will see this height unchanged and this height will be changed. Okay, this will appear higher. What you realize is that this would be simply y minus x plus z minus y into mu of water. Okay, I hope you can notice that. So this is going to be our trick. So all I need to do is I need to find the distance of the fish as seen by the bird and the distance of the bird as seen by the fish. Now, if I can find that, then to find the relative velocities, all I need to do is simply differentiate this. Okay, velocity of fish as seen by bird would be d by dt of s of fish with respect to bird. Similarly, velocity of bird with respect to fish would be d by dt of s of bird with respect to fish. So these are standard kind of problems where you have a bird, you have a fish, okay, and both the bird and the fish are moving with respect to each other, and you are asked find the velocity of one as seen by the other. This is the standard way to solve it. I hope that you guys follow this. Okay, you can let me know if there is any confusion, and if there is none, we will go ahead and practice on such problem, maybe couple such problems. Okay, okay. So here is a typical problem related to this topic. So you've been told a bird in water is diving vertically over a tank with the speed 6 centimeter per second. Now base of the tank is silvered, so this gets tricky. Base of the tank is also silvered now. Okay. Now the fish inside the tank fish inside the tank is rising upward along the same line with a speed of 4 centimeter per second. If the refractive index of water is 4 by 3, then find the speed of the image of fish as observed by the bird directly. So first, the bird is directly looking at the fish. It will obviously see an image through refraction, and what is the speed of that image of fish. And then second, image the speed of image of the bird as observed by the fish in the mirror. Now the fish is looking at the bird through the mirror. So what will be the speed of the bird as seen by the fish in the mirror? Okay, so that is what you find. Why don't you guys give it a try? Let's see if you can figure this out. Okay, so till the time you guys try this, again, I told you the standard method of solving this. Find the distances of one with respect to other, differentiate that, and that's about it. Okay. Okay. So try this, and let's see. Okay. So again, a very interesting problem. This is yeah. Let's see. Out. Okay, anybody with the answers then? So I don't know. Are you guys trying? Anybody trying? Please let me know. So if nobody's trying, maybe I'll solve this. Okay. All right. So let's see how you would have gone about. Again, as I told you. So what is the first question that has been asked of us? First question is speed of the image of the fish as observed by the bird directly. Okay. All right. So let's see. So what you realize is that this bird, let's say, is located at this distance z. Okay, this is y. This is x. So first, let's try and see the distance at this point that the bird sees the fish to be at. Okay. So what is the distance of the fish with respect to the bird? Okay, so it will be z minus y plus y minus x over mu. Correct? Okay, as I told you. So if you differentiate that, you would get therefore the velocity of fish with respect to bird would be dz over dt. Okay, dz over dt minus you would have had 1 over mu times x over dt. Read as simple as that. Now, what is the direction in which the bird is moving? So the bird is moving downward. So dz by dt will be minus 6. Please remember to put these things with proper signs. So this will be minus 6. Okay, minus this would be 3 by 4 into dx by dt. So since the fish is moving up, so the speed of the fish should be taken as positive. Okay, so please note anything in the upward direction will be taken as positive, anything in downward direction will be taken as negative. Please remember to put proper signs in this equation. So this will be minus 4 or plus 4 rather. So what you will realize is that this will be minus 39 centimeter per second. So velocity of the fish as seen by the bird would be 9 centimeter per second. Okay. I hope that that is clear. So that's our answer to the part A. Okay. The fish will appear to be moving at a speed of 9 centimeter per second and close. The minus sign denotes that it is moving towards the bird with this speed. Plus sign would have meant that it is moving away. Okay. So now let's talk about the next part. What is the speed of the image of bird observed by the fish in the mirror now? In the mirror, you will realize what where will the image of the bird be as seen by the fish. Now please note that fish is looking at the bird from water. Okay, so you know that the distance here would be the distance equivalent distance that the fish will see the bird to be in water itself. Okay, you realize this reflection is happening in water. So what will happen is, so what you need to do is you need to adjust this. Imagine that it was entirely filled with water. Then what would the distance of the bird be? The distance of the bird would have been from here. It would have been z minus y times mu plus y. Okay. So that would have been the distance from the mirror, apparent distance from the mirror, and that is where the image would have been formed. Okay, please pay attention to this. From the mirror is kept in water. With respect to water, what is the distance of the bird from the mirror? The distance of the bird from the mirror would be z minus y times mu plus y. Now, this is the distance at which the image of the bird would be formed. So, bird's image is formed here. Now, what is the distance of the image of the bird? I of bird, let's call this IB, with respect to the fish. So, that is what I need to do for part B. Okay. Now, again, this is the tricky problem. Pay close attention to this. Now, what I can say is distance of image of bird with respect to fish would be x plus z minus y times plus y itself. Agreed. So if I wanted to see the speed, therefore velocity of image of bird with respect to fish would be simply dx over dt plus mu times z over dt. Okay. Now the fish is moving up, so dx by dt is positive, so it is moving up with a speed of 4, I think. Yeah, 4. And here I'll have minus 4 by 3. And the bird was moving downward with a speed of 6, if I remember. So you will have minus 4 centimeter per second. Again, minus sign denoting that the image of the bird is moving towards the fish with a speed of 4 centimeter per second. Yes, AP 9 was the answer for the first part. You are right. We did calculate it here. Here. 9 was the answer for the first part. For the second part, the answer is 4. Okay. I hope those answers are clear to you. Human says, sir, I'm new user, unable to use Unacademy app efficiently. Okay, why? What happened? Mohit Kumar says, I'm getting 12. Okay, I don't know how you're getting 12. This is the answer. This is the solution. Okay. See what you did wrong? The second part also the answer is 4. So it is very simple. Just write the distance of the bird with respect to fish and as seen by that person. Okay. So when you are asked the relative velocity of the uh, bird as seen by fish, then you have to write the relative distance of the bird as seen by the fish. Okay, and vice versa. Okay. You must have made some mistake, Amod. Okay. So yes, human. What kind of problem are you talking about? How can I help you with that? Let me know. So if you can be a little more specific about your problem, okay, I can be of better help. I'm sure. Okay, human. All right. Okay then, and let's talk about the next problem then. So I will give you guys this problem to answer. Okay. So this is one problem. Find out from the figure shown the apparent speed of the fish as observed by the bird and the apparent fish speed of the bird as observed by the fish. Okay. So here you have been shown this figure. So a bird is moving downward with a speed of 24 meter per second. The fish is moving up with a speed of 12 meter per second. Now, interestingly enough, with the level of water is also increasing in this. Somebody must be filling water in the tank, and the level of water is also rising at a rate of 1 centimeter per second. Okay, so see this, guys. It's not live; it's recording. Okay, human. I wonder why you feel that. I think I'm trying to respond to you. Okay, all right. So I had asked you to be more specific about your problem so that I can help you. No, human. Okay. So AP says 4. 4 for what? 4 for what, AP? Okay. So human, are you sure you are human? कल मेरे साथ यही हुआ था. अच्छा. Okay, no, no, but I can assure you this is live. Okay, this is live. Okay. हाँ, so if you can be more specific, अपनी प्रॉब्लम थोड़ा और डिटेल में बताओगे तो आई कैन हेल्प यू बेटर ना. एग्जैक्टली क्या परेशानी आ रही है आप यूज करने में. हम्म. ऑलराइट, सो ट्राई दिस. ये जल्दी जल्दी ट्राई कर लो यार. सी लोग आंसर निकाल पाते. हाँ. Okay. ह्यूमन जी. आंसर ऑफ लास्ट पार्ट. ओके ओके. ऑलराइट, हाउ अबाउट दिस वन. ये वाला करो ना आप. तो ह्यूमन आपने अपनी परेशानी तो बताई ही नहीं. ओके, 133/4. ओके, ये ए का है बी का है. ओके ओके ओके. ऑल राइट, लेट्स सी, लेट्स सी। देखते हैं। All right, so again, let's go back to our equations, है ना? Equations क्या कहती हैं भाई? मान लेते हैं ये कुछ ग्राउंड का लेवल बना लेते हैं पहले कुछ, एंड ये हमारा Z हो गया, है ना? ये हमारा Y हो गया, ये हमारा X हो गया। सो पहला क्या है? अपरेंट स्पीड ऑफ फिश एज ऑब्जर्व बाय बर्ड। सो पहले तो बर्ड को देखते हैं, डिस्टेंस क्या दिखेगा फिश को, फिश का। ओके, तो ओके, डिस्टेंस ऑफ द फिश एज सीन बाय बर्ड क्या होगा? सो बर्ड को ये डिस्टेंस तो ऐसी की ऐसी दिखने वाली है, ठीक है? दिस इज z माइनस वाई एंड प्लस वो डिस्टेंस कम दिखने वाली है, y माइनस एक्स ओवर म्यू। करेक्ट, ये डिस्टेंस फिश की दिखेगी बर्ड को। अमोद कुमार नॉट अंडरस्टैंडिंग, टफ वन। ओके, सो अगेन नॉट रियली टफ वन। देखो, जब भी ऐसा क्वेश्चन आएगा, व्हाट यू हैव टू डू इज, देखो भाई क्या करना है। ये फिश भी भाग रहा है इधर उधर, बर्ड भी जा रहा है, पानी भी जा रहा है। सो क्या करना है? सबसे पहले ये देखना है बर्ड को डिस्टेंस क्या दिखेगा फिश का कभी भी। ओके, बर्ड कहाँ पर है? हवा में, ठीक है? तो बर्ड को हवा वाला डिस्टेंस तो ऐसा का ऐसा ही दिखेगा। अग्रीड, ये डिस्टेंस तो ऐसे का ऐसा ही दिखेगा, इस डिस्टेंस में कोई फर्क नहीं दिखेगा बर्ड को, ठीक है भाई? ये डिस्टेंस अनचेंज दिखेगा। ये डिस्टेंस क्या है? अगर बर्ड की हाइट ग्राउंड से z है और पानी के लेवल की हाइट किसी भी इंस्टेंट पे y है, तो ये जो हाइट होगी ये z माइनस वाई होगी। अग्री? ना, ये जो हाइट होती ये होती y माइनस एक्स, ठीक है ना? y आपका पानी के लेवल की हाइट है और x आपका फिश की हाइट है, सो ये y माइनस एक्स होता। अब y माइनस एक्स जो है वो है पानी में। बर्ड को क्या दिखेगा? ऊपर शिफ्टेड दिखेगा। एपरेंट डेप्थ, अभी बताया था, एपरेंट डेप्थ कितना दिखता है? एपरेंट डेप्थ इज रिड्यूस्ड बाय अ फैक्टर ऑफ म्यू, ठीक है? सो उसको ये जो डेप्थ है y माइनस एक्स नहीं दिखेगा, y माइनस एक्स अपॉन म्यू दिखेगा। अभी समझ में आया आमोद? ठीक है, सो दिस इज द डिस्टेंस ऑफ द फिश दैट द बर्ड विल सी, है ना? बर्ड को क्या लगेगा? फिश z माइनस वाई डिस्टेंस प्लस y माइनस एक्स अपॉन म्यू डिस्टेंस पर है। अब क्या करना है? स्पीड के लिए बस इस इक्वेशन को डिफरेंशिएट करना होता है। तो वेलोसिटी ऑफ फिश विद रिस्पेक्ट टू बर्ड will be just simply differentiation of this। जब इसको डिफरेंशिएट कर दोगे तो क्या आएगा? dz over dt minus dy over dt, then you will have plus 1 over mu, you will have dy over dt minus dx over dt। यहाँ पे क्या है? dy by dt जीरो नहीं है। पहले क्या था? पानी का लेवल चेंज नहीं हो रहा था तो dy by dt हम जीरो ले लेते थे, हम उसको बॉदर ही नहीं कर रहे थे। यहाँ पे पानी का लेवल भी चेंज हो रहा है तो dy by dt जीरो नहीं है। Okay, now please remember to put proper signs. It's, I don't know. Remember to use proper signs. ये थोड़ा टफ टाइप की प्रॉब्लम्स हैं, अग्री। ओके, थोड़ा सा ट्रिकी टाइप की प्रॉब्लम्स हैं, बट दे आर इजी टू अंडरस्टैंड। इतना टफ है नहीं अमोद, ठीक है? तो अभी क्या करना है? ऑल यू नीड टू डू इज जस्ट पुट इन दी वैल्यूज। डी जेड बाई डी टी ये आ रहा है नीचे, ध्यान से देखो सब चीज। ये कहाँ जा रहा है? ये जा रहा है नीचे, तो z रिड्यूस हो रहा है, तो डी जेड बाई डी टी नेगेटिव लेंगे। ऊपर का डायरेक्शन हम पॉजिटिव लेने वाले हैं, जो भी चीज ऊपर जा रही है वो पॉजिटिव, जो भी चीज नीचे आ रही है वो नेगेटिव। फिश कहाँ जा रही है? फिश ऊपर जा रही है तो ये पॉजिटिव ले लिया, पानी कहाँ जा रहा है? ऊपर जा रहा है तो ये पॉजिटिव लेंगे, ठीक है? एज सिंपल एज दैट। So what we will have here is that dz by dt को क्या लिखेंगे हम? -24, ठीक है? -24 लिख दिया, प्लस dy by dt -1, अगेन +1 लिखेंगे, माइनस ऑलरेडी था, ठीक है? प्लस यू हैव 4/3 का 3/4 हो जाएगा, इनवर्स है 3/4, और ये आया 1 माइनस, ये क्या था? 12, ठीक है भाई? ओके, सो ये आपका एक्सप्रेशन बन गया। तो यू हैव -25 प्लस प्लस लिया, ये भी माइनस रहेगा, तो -33/4. So obviously, if you cross multiply this, you will get -133/4. So that is the correct answer. यही बता रहे थे सब, 133/4. All right. This is the answer for the part number one. Very, very well done, people. Well done. Similarly, अब सेकेंड पार्ट के लिए देखते हैं भाई, सेकेंड पार्ट में क्या होगा, सेकेंड पार्ट में क्या होगा। अब देखते हैं, कभी भी फिश को क्या डिस्टेंस दिखेगा बर्ड का। हाँ भाई, इस पे ध्यान दो। आपका फिश है, क्या यहाँ आपका बर्ड है। अभी बर्ड को क्या दिखाई देगा, फिश को क्या दिखाई देगा। फिश पानी में से देख रहा है, तो उसको ये डिस्टेंस तो अनचेंज दिखाई देगा, उसको ये डिस्टेंस तो अपना, जिस मीडियम है उस मीडियम का डिस्टेंस अपना ठीक दिखता है उसको। ये डिस्टेंस का क्या होगा, ये डिस्टेंस उसको म्यू टाइम्स मल्टीप्लाई होकर दिखेगा। ये डिस्टेंस उसको दिखेगा, जो कि y माइनस जेड होना था, y माइनस जेड इंटू म्यू दिखेगा। ठीक है, बस ये याद रखना है, जो चीज जिस मीडियम में है उसको उसका डिस्टेंस ठीक दिखता है, बट जैसे मीडियम चेंज होता है दूसरे मीडियम का डिस्टेंस एपरेंट डिस्टेंस हो जाता है। ओके, सो व्हाट आई कैन से इज द स्पीड of or the distance of bird with respect to fish is y minus x plus mu times z minus y. ठीक है, और जिसके मीडियम हो उसके रिलेटिव रिफ्रैक्टिव इंडेक्स से मल्टीप्लाई कर देते हैं, ये बताया था। तो इसको डिफरेंशिएट कर दो, वेलोसिटी ऑफ बर्ड विद रिस्पेक्ट टू फिश कितना होगा, dy over dt minus dx over dt plus mu times dz over dt minus dy over dt. That is it. बस डिफरेंशिएट कर दिया भाई, ये कितना है +1, ये कितना है -12 प्लस ये हो गया 4/, और यहाँ पर आया आपका -24 और -1। ठीक है, what you have here is -11 -100/3. So this is -133/3. सो सही आंसर्स थे दोनों ही, 133/4 and 133/3, and the minus sign is suggesting both are coming closer to each other, which pretty obvious है ना, ये भी ऊपर जा रहा है ये भी नीचे आ रहा है, तो दोनों एक दूसरे के पास ही जाएंगे। दैट इज द माइनस साइन इज सजेस्टिंग। ओके, तो ये क्लियर है। अब ऐसे और प्रैक्टिस करके देख लेना, बहुत आसान है। एक बार डिस्टेंस लिखना सीख लो, डिस्टेंस लिखना सीख लोगे विच इज वेरी इजी, तो फिर स्पीड निकालना भी आ जाएगा। ओके, सो द मोमेंट यू आर क्लियर अबाउट हाउ टू राइट द distances, apparent distances between the two objects, then all you need to do is just differentiate that expression for a distance, and you can easily write the velocities of one with respect to another. Okay, okay, again, if there is any confusion, let me know right away, and if there is no confusion, we'll move on to the next part of the discussion. Okay, so all clear. Sorry. Okay, I'm hoping it's all clear. Okay, next we will discuss about refraction through glass slab. Okay, we will talk about refraction through glass slab. So, you know what a glass slab is? Glass slab is a plane surface of glass like this, okay, as you can see here. So, first, what we need to see is any light ray that enters the glass slab from here. Okay, now from air. So, I'm talking about any light ray moving in air, which is moving in glass. Okay, so how will, okay, our inspiration physics wala. So, okay. Again, this channel is providing quality education for free. Okay, so again, if you don't like the content, yes, you cannot, you need not come and what, but you can definitely come here. So if you like the content, you can definitely come here. Okay. So there is I don't know what you are talking about. Okay, on this channel at least free content is being given. So what can be the harm in that? Okay, all right. Okay, human. So stop wasting your time with silly pranks. No, utilize this time in your studies, Baba. Your time is very precious and limited, and trust me, this time will never come back. The preparation time is very, very important. Do not waste it on. Yes, absolutely, Amod. Amod, absolutely right. All right. So let's talk about this. भाई यहाँ पे अगर हम देखें, so if you realize, if this angle is I, if this angle is R, then this angle will also be R, and if this angle E, this is called the angle of emergence. This is what we call angle of emergence. Okay. So what you realize is from this, sine I equals sine R, mu sine R, and what you will realize is that mu sine R equals sine E. So what you realize is therefore sine E equals sine R, sine I equals sine E, or I can say I equals E. So the first thing that you will realize is that the light ray that enters from one point exits from the other parallelly to the ray that was incident. Okay, so thus the emergent ray is parallel to the incident ray. Okay, that's the first thing that you will notice about refraction through a glass slab. Okay, all right. Now, if I don't know if I can show you this. I think in the last one, I think we did have an image of showing you this refraction through glass slab. Yes, right here. So here was what I was showing you as a refraction through the glass slab. So here you can see it clearly. Okay, you can see it more clearly here. Okay, so this is very nice example of that visualization of that. You realize that a light ray that is entering from here, that's ray gets bent like this, and then it is coming out parallel to this one. You realize the two rays, the incident ray and the emergent ray, are in fact parallel to each other. Okay, so that is where you can see this is real. Which again, you can see that happening here also. If you extend this way, you will realize this and this are parallel to each other, right? So you can notice that happening here. Okay, what I was just telling you. That let's just get back. That's the first fact that I could establish about refraction through a glass slab, that the emergent ray is always parallel to the incident ray. Now, we will also talk about normal shift again. Any object that is kept here at a distance will appear shifted, okay, to this distance. And how much is the shift? Let's talk about that. So first, you will realize first, when this refraction happens, from this refraction, one image is formed here, and you know that this d dash, you should know how much will that be. Okay, so that d dash would appear to be, if the distance was, original distance was x, so from the denser medium, d dash would be equal to x times mu. Okay, the distance would have appeared increased. Okay, so I told you this. From the denser medium, the distance appeared increased. Now for this one, imagine in the glass, when this is at a distance d dash. Now from air, how does it appear? So this distance again, the image appears shifted here, and d double dash would be again how much? This entire distance, which is t plus a d dash over mu. Okay, that is the distance that you will see. So what you notice is that the distance that appears to be from here is double dash is d dash over mu, which is in fact x plus t over mu. So what is the shift? What is the shift? So the actual distance actual distance was x plus t. Apparent distance is x plus t over mu. Therefore, shift, how much has the image shifted? Shift would be t minus t over mu. Okay, so please note. So whenever any object is seen through a glass slab, it appears shifted. Okay, and it appears shifted by this amount. Okay. So hi Kavath Reddy. Revising ray optics is being a big problem, sir. Why? Why? This is an easy topic. Okay. This is an easy topic only. Why is it so difficult? Huh? Now, please note one more thing, that the shift always happens in the direction of propagation of light. Okay. So let's make a note of that. Quick note of that. Note shift always happens in the direction of propagation of light. So in whatever direction the light is traveling, in that direction you will have the shift. Okay, and the amount of shift would be this. Can you suggest best method to revise? Okay, so if there is any particular part that you are struggling with, then you can watch the lectures of this series. Okay, because in this series, this is meant for class 12 students, so I'm discussing everything in detail. Okay, so that should help you. Otherwise, right now for JEE 2021, I think mostly what you need to do is just solve your problems. Okay. Again, I would that is what I would suggest. Just practice problems, and if there are any particular parts which you're struggling with, then you can watch those lectures from my series of ray optics. Okay, that should help you. Okay, all right. So shift, I realize, is please remember this. This is an important formula that we will be talking about a lot. P times 1 minus 1 over mu. Okay, so this is the shift for this formula. Important. Okay. So we already talked about this normal shift. Again, I had left one more, yeah, page because I thought I'll be needing more. This. Okay, so we are done with this. Now, suppose you have multiple slabs. Multiple slabs, then what do you do? Okay, no problem. Of course. Now, if you have multiple slabs and imagine you are looking at something from here. So every slab will produce a shift, and the net shift would be sum of all these slabs. Okay. So please note For multiple slabs, for multiple slabs, the net shift would be uh, the sum of all the shifts. Okay, so obviously net delta x in this case be T1 times 1 minus 1 over mu 1 plus T2 times 1 minus 1 over mu 2 and so on. Even if you have multiple slabs, then the net shift would be given like this. And please note one thing, mu 1, mu 2, sorry, are the relative refractive indices are the relative mu's of the slabs with respect to the medium of the observer. This is very, very important. So whatever you are trying to find, the shift will happen with respect to the medium of the observer. Okay, all right. What you can realize is that in every medium, in the medium of the observer, every length can be shifted. Okay, and converted into a single medium. Okay, please note that. All right. Now we'll talk about refraction through parallel surfaces. So imagine there are continuously parallel surfaces lined together. Okay, there is a continuous bit of parallel surfaces lined together. This kind of question has been asked in JEE Advanced. Okay, so what you realize is that for such a surface, when the light ray is moving from one to another, what you realize is what you can write as mu one. So you will realize for such surface, you will realize that mu one sine theta one equals mu two sine theta two equals mu three sine theta three and so on. So for such cases, what you can realize is that mu of ith medium into sine of ith medium is constant. Okay, so this is the fact that you will use to solve problems where multiple layers of different refractive indices are kept together. Okay, so you use this equation that mu sine theta is constant. Okay, mu sine theta is constant, and obviously this value would be any of these values. Any mu sine theta value you calculate, and you can equate the value to be equal to that. Okay, right. Next, you have a typical problem where you have to find the equation of trajectory. Okay, where you have a medium which has a refractive index that is continuously varying. Again, here also what you need to do is you will realize here also at any point. So imagine if this is the point, and here at some x comma y, you have an angle of incidence. Okay, which is like this, I. So what you will realize is that mu at y, mu at x comma y into sine I is constant. Okay, so that is what you need to do. Also, what you will realize is that this mu. Okay, so if I know sine I also know what is the slope. What is the slope? This is 90 minus I. Okay, this is 90 minus I. This is the slope of the tangent here. Agreed. Slope of the tangent is 90 minus I. So can I say also y by dx equals cot I. So what you need to do is from here find the value of sine I. substitute here, integrate this, and then you can find the equation of the path taken by the light ray. Okay, so that is a very interesting thing. What we will do is we will first try and tackle a problem with this first, okay, and then we'll see. So again, for what you need to do is, again, you have mu, which is usually a function of y. Okay, so all you need to do is find the value of that, integrate that expression here, and find yourself a relation. Okay, so let's try a problem from this. Yeah, I did have a problem here. So I want to try this problem first so that you understand that approach. So here you've been told a light ray enters a medium whose refractive index varies with height as this. Now find the equation of the path of light. Okay, so you have been told assume that at O it is equal to the angle of incidence was equal to 90. So what I can say is I can say that mu sine I is constant, and that constant can be written as 1 into sine 90. Correct? Can I say sine I is equal to nothing but 1 over mu? Okay, so I'm getting this as 1 over root mu was 4y plus 1. Okay, so if I draw a triangle, this is I, this is 1, and this is root 4y plus 1. So what is going to be the base? This square minus this square. So this will be 4y of root of 4y. Agree? Okay, this is going to the base. So what I realize is cot I. What is cot I? Cot I would be 2 root of y. Okay, and I also know dy over dx. So dy over dx equals cot I. So that will be equal to dy over dx would be equal to 2 root y. So what I have is y to the power minus half equals 2 dx. So if you integrate this, now it passes from 0 comma 0. Okay, the curve passes from 0 comma 0. So our integration limits are going to be 0 to y and 0 to x. So what will that give you? That will give you, okay, 1 by 2 to 2 to y to the power half equals 2x. So the equation of the curve is y square equals x. That is the equation of the path taken by the light for such a medium. Okay, I hope you guys followed this. Let me know if you followed this. If there is any confusion. So this is what we are going to do. We are going to write the fact that mu times sine I is going to be a constant. We will use the initial value for that, for finding the value of that constant. So initial value being at the point of incidence, at the point where it enters the medium. Okay. Now using that, I got this relation. From here, I found the value of sine I. Once I found the value of sine I figured out the value of cot I, and I said that dy by dx is equal to cot I. And then integrating that, I could find the equation of the path followed by this light ray. Hello Arjun, how are you? Okay, so this was how the mu was varying, and the equation of the path that we are getting is y square equals x. Y equals x square. Square. Right, this is the equation. You will realize this is a parabola. Now, equation भी ऐसी लग रही है. This is what I can see. Correct? All right, so this is where I would like to wrap up today's discussion because there were a couple of things that I wanted to discuss again. Okay, so there is a matter of lateral shift. Okay, maybe we can cover that quickly. So this part is sorted. There is a matter of lateral shift that maybe we'll just cover this in the next class because we are running out of time. Okay, so yeah, let's discuss about this next class. So as I said, so first thing, what is lateral shift? I'll just tell you what that is. So, whenever a light ray is incident like this, you know that the emergent ray is parallel to this. However, it does get laterally shifted. It gets shifted sideways. So the sideways shift, this is what we call lateral shift. And the next class, we will try to calculate the value of the lateral shift. Okay. And this is very, very easy. Don't worry about it. So that is where, and then we will try a few problems also. Okay. So that is where I would like to wrap up today's session. Okay. Okay. I hope you guys followed every part of the discussion. There is if there is any part that you did not follow, and if there is any part that you have any confusion about, make sure you ask about that in the next class. Okay. Before I end this session, let me remind you that if you haven't gotten your plus subscriptions, you should be getting them. Okay, and this is how we do it. You can go to the plus section of the app, of the Unacademy app, select your goal as ITG, and click on that get subscription button. That is how easy it is to get that subscription. Okay. Now, when you are redirected to the payment page, you will have a box that will say, "Do you have a code?" Okay, so that is where you can enter this code. Okay, this code will give you a 10% off on all your subscription fees. So you can use RD Live to get a 10% off. Now you can also choose from two kinds of subscriptions, which are the Plus and the Iconic subscriptions. And then you can click on Proceed to Pay. You click on Proceed to Pay, you will also be able to choose a lot of no cost EMI options for your payments. Okay, so that will make sure that you are not feeling pinch of this payment. Okay. Now you can also go for the Iconic subscription. Okay, so this is a new kind of subscription that will take your IIT preparation to the next level by assigning you personal coaches. Okay, so these personal coaches will closely monitor and mentor you throughout your IIT journey. And along with these personal coaches, you will be getting a chance to attend a lot of IIT workshops, receive timely expert guidelines, get a study planner, and get regular test analysis sessions. Okay. Now there are also combo subscriptions available for any of you who is going to their class 11th and looking for a single one-stop solution for all their studies. Okay, you can get a combo subscription where you can get the Iconic subscription for your IIT JEE preparation and plus subscription for your CBSE 11th and 12th, or you can go for an Iconic subscription for all three. The prices of these combos are roughly 4600 and 5500. Then you have another combo where you get a plus option for all these three, and then finally you have a combo where you get plus option for your IIT preparation and Iconic for your CBSE. And again, the prices of these are roughly 3000 and 3900 a month. So make sure you choose a subscription that combo that suits your needs. Okay. Then of course you have these upcoming tests in January. Make sure you're not missing out on these. So the Unacademy Combat is going to happen on the 17th and the 31st of Jan. So make sure you are taking part in this. And of course, the race exam is going to happen on the 24th of Jan. This is already over. Now, the EM Advanced exam, it happens every Saturday, so don't miss that. And then you have unique DPPs which are getting discussed every Monday to Thursday. So make sure you are taking part in all that. Okay, thank you so much, Rajesh. All right. Now, if you like today's session, if you like the discussion, then don't forget to press the like button and share it with as many people as you want, because so that we can make available this free quality content to as many people as possible. Okay. If you're new to the channel, don't forget to subscribe and don't forget to ring the bell. Okay. And the PDF of all the slides used in today's lecture would be available for download very, very soon. Now, those of you who are following us on the JEE English channel of the YouTube, do not forget to connect with us on the Telegram app with the help of this link. This will make sure that you're not missing out on any of the lectures and sessions happening here on the JEE English channel. Okay. All right. So with that, we will end today's session. And before I do, let me remind you one final time that if you're planning to get your Unacademy subscriptions, then you can use this code RD Live. So this is my code. If you like my lectures, if you like me to mentor you through your ITJ journey, then you can get your subscription with this code and enjoy a 10% off. All right, so we will carry forward this discussion now next week, next Tuesday, that is. So till then, you guys take care of yourselves and keep studying hard, keep practicing hard. Bye bye.